Hello everyone and welcome back. We are going to build upon what we have just learned in our previous array question with this new harder array question. This question is going to flex our critical thinking a little bit more when it comes to coming up with a good solution. The question asks, you are given an array of positive integers where each integer represents the height of a vertical line on a chart. Find two lines which together with the x-axis forms a container that would hold the greatest amount of water. Return the area of water it would hold. Now I know this question seems a little bit confusing at first, but let's visualize what the question is asking us. Imagine we're given this array. This array becomes this bar chart where the value of the element is the height of the vertical line. Each element maps to its corresponding line in the order that it appears in the array. We are tasked with picking two lines that would form a container with the bottom x-axis that holds a certain area of water. Now, what does that mean? Well, in this case, the greatest area is actually from the 8 and the 9. What we have to imagine is that if water were to be poured into this, it would fill up a certain amount of water, which is equal to the shaded area that I've shown here. What we'll notice is that the area only goes up to the 8, because if this were some container and water were to be poured in here, even though the right side 9 is taller, the water would spill out over the left side of the 8. So what we need to do is return the area that this container holds when it comes to the water. And as we know, area is calculated using length times width. In this case, the length would be the height of our container, which is the smaller of the two sides, so the 8, and the width is the distance between our two lines on the x-axis, which is 3. This gives us an area calculation of 8 times 3, which yields an area of 24. So that is the maximum area that we can form from any two lines forming a container in this bar chart. Now, before we go into figuring out a solution to generate this, let's verify the constraints. The first question we might ask is, does the thickness of the lines affect the area? Meaning that if the lines cut into the area in any way that we have to account for when it comes to our area calculation, in this case, no, we can assume they take up no space. They solely represent the height of the walls of our container. The next question we might ask is, do the left and right sides of the graph count as walls? And the answer is no, the sides cannot be used to form a container. So what does that mean? Well, let's imagine we're given this array, which becomes this bar chart. We cannot, for example, take this 7 and form a container using any of the walls on the left or the right side of our bar chart. We have to use a value inside of the array in order to form the other wall. In this case, the biggest container would be formed from the 7 and the 3. So now we know that we must form a container using two values in this array. The next question we might ask is, does a higher line inside our container affect our area? They'll probably respond, no, lines inside a container don't affect the area. What this means is that if we were given this array, the greatest container we could form is using the 7 and 6, which would fill up this amount of water. Well, notice though that this 8 is taller and sticks in the middle of our container, seemingly breaking our container into two parts. The answer though is that we don't have to worry about this at all. In fact, just assume that none of the lines inside of our chosen container affect the area calculation at all. So now that we have our constraints, we can take these constraints and start thinking of some test cases. And that's what we're going to do in the next lesson.